Nestled in the heart of the American West, Yellowstone National Park stands as a testament to Earth's raw, untamed power. But beneath its serene landscapes of geysers, hot springs, and vast forests, lies a sleeping giant, a supervolcano that has erupted cataclysmically 3 times in the last 2.1 million years, each time blanketing continents in ash and reshaping the planet's climate. The last of these supereruptions, 631,000 years ago, forged the massive Yellowstone caldera, a 30 by 45 mile depression that now cradles the park's wonders. We often fixate on these apocalyptic events, imagining a future doomsday of molten fury. Yet the supervolcano's true story is far more subtle and ongoing, a saga of minor eruptions and hydrothermal explosions that have quietly sculpted its form, influenced its ecosystems, and even paved the way for the diverse paradise we visit today. These smaller-scale events are not mere footnotes in Yellowstone's geology, they are the architects of its current identity. Unlike the fiery blasts of magma from deep below, hydrothermal explosions arise from the park's intricate plumbing of superheated water and steam. Picture underground reservoirs where groundwater, heated by the shallow magma chamber, builds immense pressure until a blockage or sudden pressure drop causes the liquid to flash into steam. This rapid expansion fractures rock, hurls debris skyward, and carves craters, sometimes ejecting boulders hundreds of feet. These explosions occur independently of volcanic activity, driven solely by the hydrothermal system that powers the geysers and hot springs, and while they pale in scale to supereruptions, their frequency, one every few years for small ones, and a major event roughly every 700 years, means they've left an indelible mark over millennia. To understand Yellowstone's untold story, we must travel back about 14,000 years, to the waning days of the last ice age. As massive glaciers retreated, they released pressure on the landscape, destabilizing the hydrothermal systems beneath. This triggered a flurry of explosions, some of the largest ever recorded on Earth. The crown jewel of these prehistoric blasts is Mary Bay, on the northern shore of Yellowstone Lake. Around 13,800 years ago, a series of cataclysmic hydrothermal eruptions excavated a crater nearly 1.5 miles wide and 300 feet deep, the largest known from such an event anywhere. Debris from the explosion, including massive blocks of rock up to 50 tons, was flung miles away, some landing on lake islands, still visible today. Nearby, Turbid Lake and Indian Pond formed from similar detonations around 13,000 years ago and 3,300 years ago, respectively. Indian Pond's crater, dated to about 1300 BC, was likely sparked by an earthquake that sloshed 77 million cubic feet of water in the lake, unsealing a pressurized geothermal pocket. These ancient explosions didn't just scar the terrain, they reshaped it profoundly. The craters became natural basins that filled with water, creating isolated ponds and altering lake currents. Sediments from these events preserved in lakebed cores reveal layers of ash-like ejecta interspersed with volcanic deposits, showing how hydrothermal activity intertwined with the supervolcano's post-caldera life. After the Great Supereruption, smaller magmatic events continued, rhyolite domes and basalt flows up to 70,000 years ago, but it was the hydrothermal outbursts that dominated, preventing the system from stagnating. They ventilated the underground reservoirs, redistributed heat, and even influenced early human inhabitants. Native American tribes like the Shoshone and Crow revered and feared these breathing mountains, passing down oral histories of sudden blasts that echoed like thunder and reshaped the land. Fast forward to the 19th century, when European-American explorers first documented Yellowstone's fury. In the 1880s, the Midway Geyser Basin witnessed one of the most spectacular series of explosions at Excelsior Geyser. Once a colossal fountain shooting water 300 feet high, Excelsior clogged in the 1880s, building pressure until it erupted violently between 1888 and 1890. Eyewitnesses described plumes of steam and rock soaring hundreds of feet, carving a 100-foot-wide crater and temporarily halting the geyser's activity. Similar blasts rocked the area into the early 1890s, ejecting debris that blanketed nearby features and altering the basin's hydrology. These events weren't isolated. They echoed prehistoric patterns, clearing blockages and rejuvenating the thermal system. The 20th century brought more drama. In Biscuit Basin, near Old Faithful Black Diamond Pool, then a quiet hot spring, underwent its first recorded explosion sometime between 1902 and 1912. A photograph from around 1912 captures the aftermath, a widened vent strewn with boulders. Further blasts in 1918 and 1925 expanded the crater and birthed adjacent wall pool, demonstrating how repeated explosions can evolve the landscape over decades. Then, in 1959, the Hebgen Lake earthquake, a magnitude 7.3 shaker just west of the park, jolted the hydrothermal plumbing, triggering minor explosions and changing geyser patterns for years. Fast forward to 1989, Porkchop Geyser in Norris Geyser Basin, after years of escalating activity, exploded with such force that it left a 15-foot apron of debris around its crater. No one was hurt, but it underscored the hazard's unpredictability. The 21st century has only amplified these tales. In 2009, Walpool and Biscuit Basin staged a dirty eruption, flinging mud and rocks in a precursor to larger events. April 15, 2024, marked a milestone. The first instrumentally detected hydrothermal explosion, a small one above Porcelain Basin in Norris, captured by seismic and infrasound sensors. Just months later, on July 23, 2024, Black Diamond Pool unleashed a dramatic blast, sending steam, water and rocks over 300 feet into the air. Visitors fled as a black plume rose, damaging boardwalks but causing no injuries. This event, reminiscent of its 1910s predecessors, closed Biscuit Basin for the season and highlighted the need for better monitoring. So, how have these minor eruptions shaped the supervolcano? They've maintained its vitality. Without them, pressure might build unchecked, potentially priming larger volcanic unrest. Though no explosion has ever preceded a magmatic eruption in Yellowstone's history, instead, they've sculpted the caldera's floor, created diverse thermal features, and enriched soils with minerals, fostering unique microbial life and plant communities. Geysers like Old Faithful owe their rhythm to this dynamic balance. Explosions clear clogs, allowing predictable eruptions. Ecologically, the debris field supports specialized flora, while craters form refugia for wildlife. Even culturally, these events remind us of nature's immediacy, far more likely than a supereruption which has a 1 in 730,000 annual chance. Today, scientists with the Yellowstone Volcano Observatory monitor this restless realm with seismometers, GPS, and new infrasound arrays, especially in hotspots like Norris and Biscuit Basin. As of 2025, activity remains at normal levels. Minor steamboat geyser eruptions, seasonal ground uplift, and no signs of magmatic stirring. Yet, the story continues. Yellowstone's minor eruptions aren't harbingers of doom, they're the quiet sculptors of a living supervolcano. They remind us that Earth's power whispers as often as it roars, constantly remaking the world in ways both beautiful and precarious. In the steam-shrouded basins of Yellowstone, the untold story unfolds, not with a bang, but with a series of breathtaking bursts that have defined it for eons.